So this is a GlobeEU event. My name is Martin Hojsik. I'm a Vice President of GlobeEU and a member of European Parliament. And the topic is chemical recycling in a zero-waste circular economy. Now, I'm not going to explain a lot about what chemical recycling is because there are speakers who are going to describe this. But in essence, I think what is important to know is it's one of the recycling processes that really takes it down to molecular level. And that means that it has its role in the circular economy, but we also have to be really aware of where it fits within the waste hierarchy. We can take it positively as something which is really helping. We can take it as, sometimes framed in a negative way, it's the fourth worst, because there is still the incineration with energy, incineration without energy, and landfill. So it's improvement, but we should not, and I'm not repeating it, forget about that material recycling or part recycling like the reuse or prevention of waste pollution are much better. But still, it's really good also to have technologies out there available and functional, and not only technically functional, but also financially viable, because we cannot run the system of subsidies, that can help us to deal with those materials where we yet not have come to the possibility of the material recycling or other higher up on the waste hierarchy. But also it can be one of the ways how to deal with the legacy materials that contain some of the chemicals that we want to get rid of. We have lots of talks about what to do with the old PVC containing lead. Well, if we can get the lead out of it, there is a better way of reuse, and the only way you can take it is taking back to the molecules. But also today is about learning more about what is actually possible with the chemical recyclings. Where are its limitations? Where are the opportunities? And it's really great to have a wide range of stakeholders from, of course, the Commission, from the companies doing chemical recycling, having also civil society. But then, and I find it really, really important, is to actually have input from the companies that use the recycled materials, because the uptake is a crucial part of it. And I'm going to end here and win us a few minutes, because what we have a problem always with all the interesting inputs is not having enough time for the Q&As. And as I'm going to be trying to moderate the discussion, I would like to give a heads up to the presenters that anytime you can save, I'm going to be strict, but anytime you can save, we get a bonus of discussion. So we're not going to end early by all means, but we definitely hope to have a fruitful discussion. So let me welcome for the first panel, Auro Dorda from the Commission, from the DG Environment, Chris Gillian, who is the Chief Technology Officer of Eastman, Peter Sandkuller, Director of Sustainability in EMEA at Dow, and Lauren Weyland, Policy Officer from Zero Waste Europe. So to start with, Aurel Dorda, who is responsible for the circular economy in the DG Environment, I think is the best person to kick it off. And I really didn't pronounce it properly.
No problem, but it would be useful maybe before we have the discussion to understand a little bit why the GlobeEU group is organizing this discussion about the chemical recycling. In which context? I mean, what are your interests, particular in relation to this? Better maybe addressed from the outset.
Well, this is part of our work and trying to bring stakeholders together on the whole circular economy package. Now, of course, we have now the packaging legislation in the Parliament, but I think it's not only about that, it's about how we try to take the systemic thinking in the whole and have a systemic approach in the whole circular economy transformation that we need and trying to, as a Europe, achieve. So that from this bigger picture, look at, okay, what are the particular possibilities and limitations of chemical recycling within the whole circular economy approach.
Okay, thank you very much. But of course, I will speak to a certain extent, to a very limited extent, from the perspective of the regulators. It would have been ideal also to give the floor, maybe, and I look forward with a lot of interest to this, to give the floor first to the industry in order to hear the arguments. Of course, not for the first time. Arguments and counter-arguments, and also to listen to the NGOs which are possibly represented here. But in order to kick it off, I would say a number of elements that I have indicated also in the past to different participants here around the table. So we are looking at chemical recycling from the perspective of technological neutrality. This is not a novelty. The Commission is promoting this technological neutrality in many other areas, including also in the areas related to, for instance, plastic recycling, circular economy, and so on. So we really believe that we should assess the suitability of a technology over another, mechanical recycling versus chemical recycling versus incineration, through the prism of the environmental footprint, energy consumption, and suitability to the particularities of the materials or substances which are subject to recycling. Considering that, for instance, give just an example, for PET material, mechanical recycling seems to be the most appropriate one. So it delivers for PET recycling, while, for instance, when it comes, in particular in certain circumstances, when it comes to delivering food-grade quality plastic resulting from recycling, chemical recycling seems to be particularly suitable. Also, as you know, most of you know, or probably maybe even all of you know, the Commission, in the context which is much more narrow, much more limited, of the application of the or implementation of the Single-Use Plastics Directive, has ordered is in a way of commanded a study to the Joint Research Center of the European Commission and of the institutions about the comparative merits of mechanical and chemical recycling and incineration. This we wait in the following weeks for the results of this study. To keep to the same more narrow context, but nevertheless relevant, of the application and implementation of the Single-Use Plastics Directive, as we have mentioned several times, and some of you are very well aware, we are preparing. It has taken more time than we initially thought. We are preparing implementing acts under the Single-Use Plastics Directive. One will come, we hope to have it adopted after thorough discussions with the Member States in April on mechanical recycling. It has already taken several months more, and neither a longer delay, but still this year, maybe towards the end of the year, we hope to be able to come with an implementing act on chemical recycling. So having said this, we understand very well the interest of chemical companies in particular in the area of chemical recycling. Is one of the technology, I mean, for those who already have invested in this, it's no longer a novelty. Still, it is a technology which is more at the beginning. This means also that we still need to look into data about the performance of chemical recycling. We see different figures, maybe with different, not identical methodological background, which is released by different economic operators. The fact that the methodological background, the methodologies used for generating these data are not visible, there is not enough transparency, we are not able to assess in detail certain things. So we would appreciate in the future more transparency in this respect. But staying with this newer technology, we understand the need for legal certainty for the chemical companies. We hope that this implementing that under the Single-Use Plastic Directive will bring some certainty. Nevertheless, it will bring certainty, but under under this directive, when it comes to the wider area of plastic recycling, we still need to look at the comparative advantages and suitability of each technology which is used. And as I did several months ago when I came in a meeting organized by one of the participants here with a wider number of economic operators, I would like to share also the fact, based on past lessons that we have learned from other areas, maybe not identical, we would like to give also a message of caution. We see a lot of interest. We caution against overinvestment in this area. We have in mind, for instance, in particular, that, for instance, 97% of the single-use plastic bottles that fall under the directive are made of PET. Mechanical recycling is suitable for PET. This means that chemical recycling is, at this stage, relevant for 3% of the bottles falling under the directive. Now, of course, chemical recycling can do more than bottles, a lot more than bottles, but how to say, we believe that there should be no development of overcapacity in this area, because the tendency then is will be to look, as we have seen in other areas, for instance in incineration, you look for materials to feed your installation, which needs to function permanently. Now, we deeply believe, and it's not an ideological conviction, it's based on facts and figures. We have a number of preliminary facts coming out from the Joint Research Center that the least preferable environmental technology for recycling plastic is incineration. And the waste-to-energy operators also tell us that they are not so interested in burning plastic because there are some technological limitations and it slows down the installations. Or, as much, I'm a lawyer, not a chemist, but I got the essentials that even them are not so interested in this, because mixed waste has different components with different calorific power, which require sometimes not identical conditions. So, however, if overcapacity is developed in the area of chemical recycling, the tendency will be to withdraw from mechanical recycling what is more suitable there and what takes less energy there. So, against this message of caution, I would stop here, and I really look forward to, with interest, to hear from those around the table more.
Thank you very much. And I always enjoy disagreeing with the Commission, but I have to agree. So it's a pleasant moment. And just highlight two things what you said is one thing for me. It's really and I'm very, very happy to hear this, is the emphasis on the waste hierarchy. For me, it's very simple. Waste hierarchy should be the cornerstone of the policy, and we always need to follow it. But also I think, and this is important, and I'm happy for today's meeting because of that, especially is that there is need with the new technologies, for them to be properly assessed, there is a need for transparency. And I hope today will help it a bit, but I think there is need for more dialogue, because there is a place for chemical recycling, but we have to be properly assessing it and have the right data and kind of not overinvest, but also not underinvest. But this is always this fine balancing game, and really trying to make the waste hierarchy work and get to the circular economy without reducing the waste. So, but this is not about me talking, and I'm really happy to actually now start hearing from industry. So it's a pleasure to hand over to Chris Killian, who is the Vice President of Eastman Chemical Company. For me, Eastman is always associated with Kodak, but you don't make the films or
no.
separated.
Well, I'll give you a brief history. I sent some graphics. I don't know if we're going to use them today. Okay. They're not required. Let's go to the next page, and I will do a brief introduction to Eastman. So Eastman is a 100-year-old, little older than that company. We were a part of Kodak until 1994. And in 1994, Eastman, which was previously the chemical division of Eastman Kodak, became an independently traded public company on the New York Stock Exchange in January 1994. And so we're a 103-year-old company, but yet we're also about a 30-year-old company and as an independent entity. We have about 14,000 to 15,000 employees around the world. Our R&D headquarters in Europe is just up the road in Ghent, where we have more than 100 technical team members. We have 1,700 R&D resources today, with 85% of our growth investment in the area of sustainable innovation. And we have, focused on sustainability for many years, but there's been a strong pivot in our strategy, which really has three dimensions. And that is concern in addressing environmental issues, mainstreaming, circularity, and then what we call caring for society. And caring for society can take on a variety of forms, but one of the ways in which we do that is there are materials of concern that have been identified in REACH legislation or FDA in the US, and we've developed technologies over the years and have a proven track record of developing alternatives to materials of concern in the industry. So that's a little bit about Eastman. The next page highlights the opportunity and the problem that we have in front of us, because it's absolutely both. There's 300 million metric tons of plastic produced globally every year, and 12% of that is recycled. So not only does that put a burden on the environment and put a burden on the incineration, because those are large. Landfill takes about 40% of that. And then, as you can see, 25% of it is incinerated. And then, unfortunately, the most regrettable of all, about 20% of it finds its way into the environment. That is the unfortunate part. The fortunate part is there's a tremendous opportunity here, because every ton of that 300 million metric tons is based on fossil fuel derived materials where you can recapture and not waste that material. The next page highlights a little bit of an emphasis, I know not just for Eastman, but I think for society overall, which is reduce, reuse, and recycle is absolutely essential. So here, very clear for me that Eastman and the chemical industry is supportive of this mantra that's been in place for many years, but also recognize that our view is that plastics are essential. They're essential for hydration, they're essential for feeding the world, and also for care, whether that's in medical applications or others around the world. but we have to be responsible. And what I would say is chemical recycle is in fact essential for the reduce, reuse, and recycle vision to actually take form. Because of that 88% of plastic that's produced that is not recycled today, a portion of that absolutely needs to be recycled through chemical or mechanical recycling. There's a portion of it that also absolutely needs to be mechanically recycled. But that 88%, we're not going to close that gap through just mechanical recycling. Next page highlights another important point, because one of the things that comes up often, and many would say, hey, why don't we just eliminate plastics altogether? And to me, that is certainly a conversation and a debate we can have, but there's significant implications to such a choice. Not only societal care and standard of living would change dramatically. Third world parts of the world, it would be very difficult to hydrate and feed. And then the environmental impact would be substantial. You think about a recent study by McKinsey and Company where they looked at 14 different in-use applications, in which 13 of those applications where plastic was used and considered versus its alternative. That could be aluminum, that could be glass, that could be paper, depending on the in-use application. In 13 of the 14, the greenhouse gas implications for the environment were substantially improved using a plastic based material. And so a choice to move to all glass, a choice to move to all paper, a choice to move to all aluminum is a choice against greenhouse gas implications on the environment. And so that's something that's important, I think, for us to consider as an industry, absolutely, and as legislative bodies and municipalities around the world. The next page, I want to try to demystify a little bit chemical, molecular, enhanced, advanced recycling. What is that? Well, first of all, the reason it needs to be demystified is a bunch of different things. Chemical, and you mentioned that there's different numbers and different perspectives and different commentary. It's because the chemistry associated with chemical recycling is very, very different. And if I orient you to this page here, you see across the top the different chemical recycling technologies at still a very general or macro level. Through the middle of the page is your traditional fossil fuel based process for producing plastic materials. And across the bottom, you notice that to the left is higher energy process, and to the right, lower. And to the left, the finished product quality is really based on the technology itself. And to the right on the page, the finished product quality in the in-use application is really feedstock dependent. And the two places in which Eastman is playing commercially today is in the area of depolymerization and in the area of gasification to synthesis gas, and then the production of fine chemicals and polymers, including our bio-based cellulose materials from that technology. And as you can see, as you move along that continuum, you move from blending of polymeric materials to the deconstruction of polymers back to their constituent building blocks. And I know I'm not a lawyer, I'm a chemist, and so not everybody in the room is familiar with what a polymer is, but think of a chain, a simple chain, right? And every link of the chain is a monomer. And if you can take that polymer apart back to its individual chain links and then reassemble that chain, you've built the polymer back in its identical form with its identical quality and performance to the original polymer. And that's what we're achieving through this depolymerization technology. And the next slide goes into a bit more detail around that and tries to graphically share with the group what we're trying to accomplish here. And so we take recovered polyester materials, hard to recycle materials, and like you say, just a small amount of the unrecycled bottle materials, but trays, textiles, and other materials that are much more difficult to recycle. We put those through a mechanical purification process to sort the polyolefins from the polyesters, and those kinds of steps take place in that second step. And then we do a depolymerization. That's where we take that chain and we take all of the links of the chain back to their individual component, and then we purify them. In the same way we purify the material that comes from a fossil fuel-based feedstock. The difference is we produce on a monomer basis or on a polymer chain link basis, we do that at 20 to 30, even 40, 50% improved greenhouse gas efficiency versus comparing it to the fossil fuel-based process. And then you can see what we can do is that put it right back into our existing polymerization infrastructure and repolymerize those monomers into either packaging materials or durable goods that can be used for years and years and decades at a time. And so what this will allow is actually upcycling. You can take a material from a bottle like this and convert it into a medical device. Mechanical recycling, unfortunately, because of its energy efficiency, it'd be fantastic if it had that same capability. But you typically see you go from bottle to bottle, or actually you downcycle over time. And so the way we view chemical recycling, and it's highlighted on the next page, is it's highly complementary. It's not a competitive technology, it's a complementary technology to mechanical recycling. If you're going to achieve the objective of reduce, reuse, and recycle, for that recycle vision to be achieved, you need a combination of chemical or molecular recycling and mechanical recycling. And in fact, today, most mechanical recycling processes add back between 20 and 50% virgin material to that stream. Why? To make sure that the performance attributes are equal to that of the original material. Because any polymer, no matter what the chemical composition of the polymer is, once it goes through multiple heat histories, high temperature processes, it degrades slowly over time. And so in the future, where we have enough infrastructure for chemical recycling, the virgin PET in this cycle is replaced by chemical recycled materials. And so we're reusing the fossil feedstock-based materials. The next page highlights the reality of this technology, not the theory, not the hypothesis of this technology. The first U.S. investment that we're making, that we began construction on a couple of years ago, greater than $300 million, approaching that of $400 million. I had the opportunity to walk through that facility on Friday before I came today. It's an enormous and complex process. It is where all of the major unit operations are installed, and all we're doing at this stage is doing the piping and the connecting of those major unit operations. And we'll be operating that plant and producing dimethyl terephthalate and ethylene glycol that will be used for the production of PET and other polyester materials later in 2023. So it's a reality. It'll be done at a scale north of 100,000 tons. We also recently announced an investment in France in the Normandy region, and in partnership with strategic brands like LVMH, L'Oreal, Danone, and others, to invest $1 billion in a molecular or chemical recycling facility in the Normandy region. We also recently announced a partnership with PepsiCo in the U.S. to do a PET packaging project. It'll be on the order of that $600 to $800 million, where we'll be making PET, taking recycled PET back from hard to recycle materials, converting that back into PET that can then be used in the production of carbonated soft drink and water containers for Pepsi, as well as likely some textile applications as well. One thing that companies like Eastman and like Dow, who will address the group here in a minute, need from the commission, need from the municipalities in the U.S. is as a legislative environment that encourages innovation. a legislative environment that recognizes the size of these investments in proportionality to the size of our company. So we're a $10.5 billion company investing, let's just call it a little over $2 billion in the circular economy. And we need that legal certainty. We need that ability to innovate. In fact, if you were to rewind the clock 10 years ago and say, what is recyclable then versus what is recyclable today, it's very different. And when we roll the clock forward to 2033, 10 years, what will be recyclable then and what the technology will be able to do later at that time will be vastly, vastly different than the technology today. So with that, just want to thank the group, and I look forward to the conversation and questions later.
Thank you very much.
Yeah.
I'm tempted to start asking questions myself. Not gonna do
Write them all down and then we'll answer them later.
I have no way. Yes, that's what I'm doing. Peter Sandküller. I might have the German right, no?
Yeah, you got it.
Almost there. The Director of Sustainability for Dow Chemicals. Over to you.
Thanks a lot. And after the speech, there's not so much to add, but let me give a little bit of an additional perspective on, after hearing about polyester, what this eventually means for polyethylene, which is today the largest polymer on the planet being produced, and how we look at circularity and decarbonization of the industry as well. So let me start with, and you cited the McKinsey study as one of several that actually show that plastics are probably materials that we want to use in society because of the product carbon footprints that they offer and the lightweighting. So with that in mind, alternative materials don't always offer the same overall benefits. Now, we all are here because we want to drive the circular economy, recognizing that end-of-life states like environmental discharge or basically incineration are linear models, and we want to drive circular models. With that in mind, I think we look at decarbonization and circularity as two sides of the same coin. Because decarbonization affects our processes, we need to reduce the emissions from, and chemical production is a heavy CO2 emitting industry. We need to reduce these emissions. We have a plan, I think 100 kilometers north from here, where we have a multi-generational plan in Terneuzen to reduce the emissions from that site gradually over time to a net zero scenario. That is a massive undertaking, very costly. On the other hand, we also look at circularity for our equally important Scope 3 emissions, meaning the fossil feedstocks that we're using today, which we ultimately need to replace or want to replace with alternatives. And there, bio-based materials is an option, or bio-sourced, bio-based sources. But in our view, that is not sufficient from a quantity perspective available, and also from a cost perspective today, to really come into at that scale that the chemical industry ultimately would need it. And we all hear last September or last December was the ambition of potentially having 20% of the fossil feedstock to the chemical industry being non-fossil based. So that, I think, is also an ambitious target to really drive the whole chemical industry towards a more circular spectrum, not only in plastics. And I think in that spectrum, we have mechanical recycling, we have chemical recycling, and these are all complementary to provide alternative feedstocks to the overall plastics economy. And these are important elements where they are really complementary. If you look at LCAs, and there are a couple of other LCAs next to the expected JRC study out there already, which show that if you look at an application like food packaging, let's say the Consumer Goods Forum has published something which is, I think, we expect it to be in line with what the JRC report will say, that you have essentially incineration, which has a very high carbon footprint as an end of waste treatment, and then you have options like chemical recycling. And because there are different technologies, you also see different carbon footprints for chemical recycling, because there are also technology innovations. There are different ways to install these technologies, which all play a role in the overall carbon footprint of these technologies. Mechanical recycling, as already mentioned, has the lowest carbon footprint of these recycling technologies, so we need to use it, and it is already used at scale. There's no doubt around it. I mean, we have 1.2 million tons in Europe being mechanically recycled in film applications. A lot of that is polyethylene. So this but, and now comes a but, for flexible food packaging or sensitive applications, mechanical recycling, in our view, in polyolefins will not be able to provide over the next years. I can't see that, and I've spent a lot of time in this industry, like 18 years. I can't see that providing the food quality and safety for food packaging applications, and that's a sizable chunk of the use of polyolefins in Europe, at the quality that we all want to have for the consumers to be safe. That doesn't mean that we shouldn't reduce where LCAs and others mean that plastics is maybe overpacked, or plastics is used for overpackaging food or other items. There we need to really have a clear idea where we really need to use it, and where it's from a waste hierarchy, where can we avoid waste. But nevertheless, there are applications where we really need for food packaging quality materials. And in that respect, you have also seen that at scale, chemical recycling can provide that. There is a dual objective, if you will. On the one hand, we want for food packaging applications to be able to provide circular materials, also in line with the PPWR 10% mandatory recycled content targets. We still think it should be 25, because that would really have a more ambitious target overall. And Plastics Europe has called for that. We think that is still a meaningful number, because that would also address the overall ambition to move away from fossil feedstocks at the same time. It's not only to build new capacity, but it's basically to be able to have a meaningful transition away from fossil fuels in this industry. The last point I wanted to make is an example, or two examples. One is Böhlen in Germany, where we have announced 120 KT input plastic waste from municipal solid waste. So out of municipal solid waste, we will take plastics that people have put into the really gray or black trash bin, and that will be moved to our facility and via a pyrolysis technology, one of the lowest carbon intensity technologies that we are aware of. We will install a plant there that will provide pyrolysis oil and gas to a cracker. Cracker is the first stage of a chemical process that ultimately makes polyethylene and other chemicals. And in that process, we can eventually use both the gas and the oil coming out of the pyrolysis unit, simplified speaking, pyrolysis unit. So there's a high yield of that. There is no gas being used for fuel purposes on that unit. But then when you go to a cracker today, or a first big scale that is very energy intensive, you need to go to 800 degrees. If you do that today, there is what is called pie gas, is a fuel, if you will, is used as a fuel to heat the process itself. And that is ultimately something we don't want to count. So the fuel use exempt model is meaningful to us. Yeah. So that we actually allocate two products that are going back into the cycle, these let's say pyrolysis credits, if you will. However, if you take that from a long-term perspective, because we need to decarbonize these assets, we will need to look at how do we take, we electrify them. That is a long-term plan in Terneuzen, for example. Intermediate stages will take the gas that I mentioned, which is used for heating, to actually separate it, extract hydrogen, which would be clean because the CO2 would be stored or later used as well, and take that back into the process, so we would be not emitting CO2 from these processes anymore. And later in electrified scenarios, the hydrogen would be used to make raw materials or feedstock for this, so circular feedstock again. And in order to do that, you would ultimately move away from any fuel in these processes being used as fossil, let's say, energy providers. And with that, we look at a scenario where, not today, unfortunately, we would love to have it today, but there's a technology readiness evolution for these assets that produce that. I mean, they're massive, and you're welcome all to visit Terneuzen to see how this looks at scale. But this is a scenario how we see really this complementarity of many of these processes to drive to a waste reduction. And there's enough waste out there in Europe that we still need to collect and bring back into a circular economy and not incinerate them on the polyolefin level. I think that is a very clear statement. But that I stop here to leave also a little bit of time for discussion. I see that we're already pretty late.
Thank you. And one note on that, indeed, I'm looking back at the 300 million annually. I think that's the feedstock, and that's where also I'm always concerned seeing the projections of increased plastic pollution and about production. I don't think we can produce more plastic. And then what I don't like is going to the shop and having the snacks for my kids in a plastic, talking normal shop, not zero waste shop, and then opening and having lots of small packages of plastic. So I think what we just keep on reminding that we need hopefully less feedstock, but then seeing what can be used and where and how to make sure that this all the entire adventure ends up in less than 30 years in a place where there is no zero waste. The last panelist, Lauren Gela, and I'm not sure, I hope I didn't pronounce your surname wrong, and you are a zero waste Europe policy officer on the chemical recycling and plastic to fuel. So, over to you.
So, just Lauriane Vega for the pronunciation.
And my French is clearly non-existent.
So, I prepared some slides as well. We can go directly to the second one. So, yeah, this one. So, just for you perhaps to speak about Zero Waste Europe. So, we are an NGO working with members present in 27 different countries in Europe, and we have 34 members, so from Ukraine and in Portugal as well, in the Balkans, so quite a lot, and really involved in the discussion around circular economy, focusing mostly on having solution on the ground at the local level, but also interacting at the EU level at Zero Waste Europe. So you can go on the second slide. So what I would like to focus now is really much more on the upper part of the waste hierarchy. So thing is that for now plastic is really made of fossil fuel, and it's the business that we know now is really unsustainable. So that's something we need to have into account. And based on our latest study, Unomia did for us, we see that with the current system plastic is working on, they will kick out the carbon budget by the plastic alone. So the idea is that all the different scenarios that has been now taken into account will not help the plastic industry meeting the 1.3, like the limits, the global warming to 1.3 degrees. And so there is a lot of question of also reducing the use of plastic, and that's something that we really think is important to have into account. So that's really, again, the yes hierarchy. So what we are speaking about is always to have prevention on the use of plastic, reusing, and then when it comes to recycling, there's of course a hierarchy when it comes to the possibility we have and also the climate impact. We can go on the next slide, please. Yeah. So what we see now is that when plastic is produced, we need to keep in the system as much as possible. So what is important is really to first go for reuse when possible, because there we don't have any leakage when it comes to plastic, but also carbon leakage. And afterwards, when it comes to the use of plastic and recycling, we made a study on the packaging. So our study was mostly focusing on pyrolysis, as it has the strongest climate impact and is more energy intensive when it comes to chemical recycling. So we are really comparing pyrolysis, mechanical recycling, and then having also taken into account the reuse aspect. So what we've seen is that comparing mechanical recycling and pyrolysis tends to emit around 9 times more than mechanical recycling for plastic packaging. So this is something that we have to take into account. And when we are producing and tackling plastic, chemical recycling has to arrive not as the first solution. And so that's why for us it's really important also to consider reuse, because it gives first also another reduce climate impact. We can see between the second and the third graph that there's a reduction even more when it comes to the climate impact. So also it's also really key, and that has not really been mentioned here for now. I think it's really what we speak about, design for recycling, and I think there the manufacturer has really a place to have, because there's lots of numbers saying that 80% of the emission related to the end of life activities can be avoided with a real and true design for recycling. So that's really something we have to move forward, and I think it's really great to have here around the table plastic producers, also plastic recyclers and manufacturers, to really have everyone here on the table. And so what we know and say is that chemical recycling has a role to play, and we acknowledge this, but we also to understand that it's really a new technology, and we have to consider every parameters, and so each recycling technology has a place to have in this discussion, but it really depends on the type of material and the context. And what we really are afraid of is that the strong push we see in chemical recycling and being able to handle really different type of plastic is that there will not be enough push or move forward at the upper, like the manufacturing aspect of plastic when it comes to products. So this is something that we really need to have into account. And also with all of this question on the development of chemical recycling, for us, the transparency is key, but as well all the question of traceability when it comes, for example, to food contact materials, and we need to know what we have inside, but also all this yes, around the circularity. So for us, it's really key, and I think I will also like win a bit of time here and finalizing now.
I'm going to be cautiously optimistic. Because we have 3 more speakers, 5 maybe. We actually might have 45 minutes for this. I'm gonna keep my fingers crossed. Thank you very much. Because now I would like to basically start looking at the uptake sector. And I have to say, flooring is not maybe food contact materials, but it's a feed contact material. And one wants to have a not only very comfortable and nice looking flooring, but also a safe one and a circular one. So, what is your take on chemical recycling?
Yes, thank you, Martina. So I will bring you into my world, which is the flooring. So Target is a world leader in floor covering and sports surfaces. So I will not give you many figures, but we are 12,000 people working at Target around the world, and we operate 34 factories, which means that we have an important industrial footprint in Europe, in the United States, and in Asia as well. We serve our customers and end users where people and planet matter. You find our products in the workplace, in healthcare, in education, in homes. Next column. Thank you. In homes, in sports, outdoor and indoor, and we offer a broad product portfolio. Our products are typically carpet tiles. On the next slide, Roland. Yes, thank you. Carpet tiles, we produce wood and laminate. We produce as well indoor, outdoor surface, so athletic tracks or artificial turf. And indoors, we are as well a leading producer in vinyl flooring, as well as linoleum. So as you can see, we cover everything from plastic to renewable, and to do that, we have the circular design at the core of Target operations, and Roland. I will not go into the details on how we work with circular economy, everything we do to make sure we eco-design products, we can recycle them. What is important for us is that we are applying cradle-to-cradle principle because we want to enable safe chemicals flow in the circular economy. That's very important, and that's as well what drives us regarding recycling. Next slide. So, to come up with the recycling topic, which is the specific aspect we want to talk about today regarding circular economy, we want to stick to the waste treatment hierarchy. So we co-design products and we prioritize in-house mechanical recycling for carpet tiles, linoleum, and vinyl floors. We do that because it's a low-carbon technology. It's safe for people and the environment without degrading technical performance of products. And we rely on our own restart collection system and in-house recycling capacity. For us, chemical recycling should remain a complementary technology to mechanical recycling, but I think so far, for the moment, we are all aligned on that. That's great. So I took two examples to show you how we move on the waste treatment hierarchy. I try to be not technical at all, but just to tell you what we do. So regarding carpet tiles, we work on nylon yarn regeneration. So Target has an in-house capacity for separating nylon yarn from our eco-base carpet tile backing. So the carpet backing, the eco-base, is directly recyclable in-house in new carpet tiles. And we separate the nylon, but for the nylon, we cannot. We need a specific process. So this is done through a collaboration with Aquafil, who is our supplier of nylon yarn, the Econil yarn, which is regenerated from the yarn we provide, but as well, Aquafil is recycling gauze fishing nets, as well as textiles with the same technology because this is nylon as core material. Then we combine two technologies, what is mechanical recycling possible in-house, and we have this partnership for regenerating the nylon. Next slide. When it comes to vinyl floors, so the legacy is the challenge, I would say. So Target only recycles own vinyl floor in our recycling plants because we know what we have put in our vinyl floors and we master our technology. However, and it is global for the flooring industry, the potential legacy content of old floor coverings, which are long-lasting products, we are not in packaging. Our products remain 10, 20, 30 years in buildings. So here we have issues with, we do not know what is their formulation and composition, or they contain legacy chemicals that are not allowed today anymore. So this is really an issue today, because if we want to move forward, we need to separate the legacy additive with new technologies. So this is something that we are investigating as an industry. For instance, we are having a joint project. Roland, can you move to the next slide? Which is the circular flooring. So this is ongoing research driven by a consortium of which ERFMI is coordinating. It brings together the Fraunhofer Institute because it is based on the Creasolve system they have developed already for packaging and other plastics. We work with producers of vinyl. We work as well with Ineris because it is important that the process that will be coming out of this research is safe for the environment. Ineris is the French Institute for Industrial Risk Management. And we work as well with ThinkStep, which is the life cycle assessment company. So this work is supported by an Horizon 2020 grant, and the idea is that at the end of this research, we will have developed a technology allowing us to separate legacy plasticizers from resin. The resins, the PVC resin, being recyclable in the producer's process. So you know it's kind of a laser technology where we just use the chemical recycling and the chemistry for dealing with what needs to be dealt with. Here that would be separation and further treatment of the legacy chemicals, of course, afterwards. So my conclusion, and again I will be probably consensual today, is that there is a need and room for different type of recycling. For environmental protection and greenhouse gas emission control, we really need to follow the waste treatment hierarchy, because that will be where we will have the best balance regarding greenhouse gas and energy and environmental protection as well. Transparency is key in value chain, and it's a must, and I will not enter into how Target is driving transparency. There is a backup slide where you will have more information, but we are a company who disclose down to 0.01% the content of all our products, meaning that anyone knows what is in a Target product, and we know what is, our customers know what is in our product. That will be important for a digital product passport in the future. But then chemical recycling is important for how to recycle material or when there are legacy chemicals. Of course, regulation, predictability, and standard frameworks allowing it in the right way is needed. And that's where we need the support of the policymakers, because if we don't have visibility, there might be no consensus on chemical recycling at the end. Thank you.
Thank you very much. Always sometimes wondering if you're not actually standing on one of your products. But actually moving from the flooring to something, I don't think personally I'm more comfortable, because I'm always saying that why to stand when you can lay down? Over to Chico van Hemert from the return mattress.
Yeah, thank you, Martin. You have the slide probably also ready. Yeah, great. Yeah, Return Mattress, a company founded in 2010. So we are on a much smaller journey than Eastman, but also involved in chemical recycling already. But it started somewhere else, actually at collecting waste mattresses. And in the meantime, we are transforming mattresses from waste to resource, actually. Next slide, please. On the left side, as is it today, 40 million mattresses are disposed annually in Europe. And with our company, we have a recycle capacity of 2 million mattresses per year. So far from the 40 million, and we are trying to our best, and this is the reason why we are also here today, to get rid of some barriers we are facing to come to this amount. Because as it is today, mattresses are produced. The lifetime of a mattress is approximately 10 up to 15 years, and thereafter it ends up into landfill or in incineration nowadays. We also we also push the waste framework directive forward, but on a certain moment people want to get rid of the mattress, unfortunately, and reusing the materials. You don't want to do that because of hygiene reasons or comfort reasons anymore. But it all starts with a proper collection. It's very important to come to chemical recycling, for example, or mechanical recycling, to collect them separately from other bulky waste. And in the case of mattresses, it's also very important to collect them dry, for example, because if the material is wet, it's very smelly and also very difficult to chemical recycle at the end. If you can go to the next slide. So if you're able to collect all these 14 million mattresses properly, we could save 3 billion kilograms of CO2 emissions. That's a huge amount in the European Union at the end. So what our company is is doing right now is not only dismantling mattresses, but also producing out of the polyurethane foams carpet underlayment, and we are also transforming our polyurethane foams into polyols, and these polyols can be used for the production of new foams, one of the main building blocks, and these new foams can be used inside of new mattresses. So we're really closing the loops by then. But as I said, to come to these great numbers, we have some challenges with cross-border transport, because the mattresses, on the moment as people are disposing it, is seen as waste. And it's very strange in my opinion, because today, therefore, you're still sleeping on it and it is a product. And on the other hand, sometimes it's really unclear if we are talking about waste or if we're talking about a product. So also here by my request to come with very clear definitions when it's waste or product, because it makes our life much more easy to work together into the complete value chain. But because most of the production companies, they do not have any waste permits to deal with these type of materials. I want also to make clear a very big difference between the mechanical part and the chemical recycling part. So if we go to the next slide, we are going to walk through of our factories where we are literally dismantling the mattresses. And these mattresses are coming for 75% from municipalities. And these are all dry because we are collecting them in closed containers. The other 25% of the materials are coming from hotels, hospitals, etc., where mattresses can came from. I heard already something about product design, and I think this movie is going to show why it's very important to think about this topic as well. Because after dismantling, most of the materials are sticked with glue on each other, or are sticked with different type of fibers on each other. And if you have contaminated products, it's very difficult, especially for chemical recycling, because you need a very pure product to come to a product which can be reused. This is the foam where I was talking about, which can be used in the meantime for chemical recycling. Dow is also focusing on this topic, because at the end it's a very used amount and we can save a lot of CO2 over here. We are currently focusing most of it internally, because there is not a complete value chain to reuse these type of products. For example, if you look to the rebond foam market, and rebond foam is a family name for carpet underlayment, acoustic material. It's not growing, it's not decreasing, it's quite stable. So if we are collecting, recycling more mattresses, then we have to look also to chemical recycling to be able to do something good with the raw material at the end. So I also am going to say it's complementary on each other, and you need both to come to a circular economy. Thank you.
Thank you very much. Now, not only playing this, one survives, and we need to eat, so I'm kind of using this to help myself to get over to Nestle. We should have Christian Detroit online. He couldn't make it, so over to you.
Thank you very much. Thanks for the invite, and apologies that I'm not in the room. I hope you can hear me well, and I will also share my screen in a second. Hope that works as well. I have not prepared anything about Nestlé, assuming that most of you will probably know that we're a big globally active food company that is producing everything from infant nutrition, culinary products, confectionery, coffee, to water, and even pet food. And we're using all type of packaging materials, and in total they make about a bit more than 10% of our greenhouse gas footprint. And of course we have an ambition to reduce our greenhouse gas footprint to 0 by 2050. The biggest lever there is our ingredients and all the agricultural goods that we're taking up. But of course, the packaging materials are very visible and branded, and we are often blamed to be the biggest plastic polluters on the planet, or amongst those. And we can debate about whether this is true or not. There is something that we have to do about it. That's for sure. So we have a vision that none of our packaging, and that is not limited to plastics, but including them, obviously, ends up in landfill or as litter or somehow in the environment. And in order to get there, we have foreseen to play an active role in the development of what we call systems for recycling, which is not our core business, but we're engaging even beyond our extended producer responsibility in the build-up of recycling, collection, sorting, infrastructure, and even providing kickstart capital to do so. We have also made a commitment about the recyclability, and I'm glad to hear from Zero Waste Europe that this is a key thing, and because here we obviously agree very much, and we are in the process of making all our packaging recyclable, which we will achieve in 2025 or briefly beyond that, because some of the infrastructure built up is not as fast as we were foreseeing. So a lot of the plastic laminates that were different materials or combinations of different materials are going to polymers like PP, PE, or combinations of those. Some of the materials going to paper as well, and we make sure that whatever we do there is recyclable. Now, the paper part obviously also helps to the third part of our commitment, which is the 1/3 virgin plastic reduction by 2025 as compared to 2018. And here is not only moving to paper, which is for the moment still kind of a niche thing, because paper does not provide enough product protection. It's also about lightweighting of, again, all our packaging materials, but plastics in particular, what we call fit for purpose packaging, avoiding unnecessary packaging elements or packaging volume, but also reuse and refill, and which is the topic of today, using recycled plastics, which we start to do in actually quite significant scale for example, our water bottles, but also some other applications. And I will dig into that with the next slide to just show and emphasize once more to the one theme that we all seem to agree, that mechanical and chemical recycling are complementary. So what we have been implementing over the last 3-4 years now is 50% recycled polyethylene in shrink film. That is mechanical recycled material that is not in direct food contact, which allows us to do that. And we are using also post-consumer material here, but let's say the bulk of the feedstock for this recycled material comes from collection in retail or logistics, which is quite pure type of material that is not heavily contaminated and can go into shrink film applications again. So it's not a downcycling, it's basically remaining in the same circle. Then still on the mechanical recycling side, we have PET bottles, and we are ramping up our recycled PET content here, mechanical recycled to 50% in 2025. We're currently at about 25% as of last year, with some key brands that have 100% recycled PET in some SKUs. So that is actually possible, but like it was said before, when you loop these materials at 100% content, it starts to degrade, even though mechanical recycling of PET also repairs part of that. You will see some color deviation, and putting some virgin material or chemical recycled in future will help to avoid that. And then on the chemical recycling side, we start to use recycled polypropylene and polyethylene in direct food contact, applying mass balance for these processes, and we see only a low availability, even though for us currently it's the only way to go into food contact. And just to give an order of magnitude here, PET bottles, rPET was the biggest part last year, in the order of something about 30-35 kilotons. Shrink film is below 10 kilotons, and this chemical recycled is a few kilotons left and right. This leads me more or less to a few asks, and I think I'm repeating here also a few things that have been said today. We would, of course, appreciate a clear signal that chemical recycled plastic counts towards recycling quotas and to recycled content targets. And we need that now, because as we have seen also from Eastman and Dow, we're speaking about hundreds of millions of investment. And if we don't know if at the end this engagement really counts, that's not helping to kick these investments off. We need obviously fair and clear rules for the allocation of these mass balance materials. And we need those fast, because also the rules must be clear to really make the business case and unlock the investments. And I'm saying here fair also because, of course, we can do it in a way that is optimized for greenhouse gas impacts or optimized for I don't know what. If at the end the business case doesn't work and there is no economic sustainability to it, it's not going to happen either. And then, of course, we would hopefully see a scientific and fact-based public discussion about it, and in order to ensure that we're doing the right things for the environment, for the economy, for the regulation, and ideally for the entire single market, because here we have an opportunity to do something more or less from scratch, from greenfield, and yeah, we don't have to deal with the legacy of recycling patchwork all over. So let's take this as an opportunity to come up with something that really works for everybody equally. And that's what I wanted to share as an impulse.
To prepare the voting list and stuff with our prep meeting, we are going to have the due diligence plus for the construction materials for vote. Well, that was almost as challenging as Palestinian issue, but so I don't know. I tried to prepare myself with the Palestine. So please do forgive me if I pose some of the questions during the discussion that you already explained or discussed, and I'm trying to catch up myself as soon as well as possible. But before I put some of my points on the table, I would like to open the floor for the others who have followed the discussion for Q&A.
Do we have any questions online?
No, not yet.
Not yet. Okay.
So I guess
I have piggyback questions, but then also feeling selfish. So any of the other present guests have questions? No. Okay, go ahead. I'm happy. No.
then you go and
For me, the kind of a guesstimating question. Well, two questions. One thing is for the industry is, and where do you see, especially for Eastman and Dow, where do you see, in so to say, in your projection, order of magnitude, the space for chemical recycling? Because that's something which is also, it's hard to judge. There is clear need from the industry for feedstock, but then also, I think what is important to see how it's your within the reasons, within kind of the possibility what you can go out public, the global space for chemical recycling. And second, a lot was talked about, for me, the low-hanging fruits and the easy materials. But one legacy material I've been tackling for a long time here, and that's the legacy PVC. PVC generally is very tricky and for me nasty plastics, but there is a lot of old PVC to deal with lead in it, and chemical recycling is one of the ways to get potentially the lead out. So if you see any opportunities in this area.
I mean, I can comment on it in the context of polyester, which is the area that we've looked at. You know, our view is there could be multiples of the investment that we announced in Normandy and still not, but barely scratch the need for chemical recycle to complement mechanical recycling. And so, you know, is that, because this is a very regional problem. It's not that we're going to ship waste around the world. So these assets, these projects will need to be stood up regionally. That's the two that we've announced in the U.S., one in Europe. There'll be more to deal with the polyester that can't be recycled today. We talked about the global numbers, but even just the European numbers alone are tens of millions of metric tons of material, polyester materials that are available. Each plant that we're building, so the one in Normandy will be done in 2 phases. The first phase will be about 100,000 tons. Second phase will be about 100,000 tons. So think 200,000 tons, and then compare that to the millions of metric tons of material that's available. And so I think we're a long way, decade plus, before we have to worry about over investment, probably multiple decades before we have to worry about over investment from a polyester perspective. If we're going to drive true closed loop, true circularity in the system, allowing for moving from clear bottles to colored bottles to non-bottle materials like trays that are prevalent heavily in the European food markets, and then ultimately to probably the greatest challenge for recycling, which is textiles. For a lot of reasons, textiles pose some of the greatest challenges. And back to design for recycle, if textiles were designed for recycle, which they're absolutely not today, there would be certainly an opportunity for a greater pull on polyester based chemical recycling technologies. I mean, fortunately, we believe through our multi-generational technologies that we're developing, we can manage textiles, but everything in there, in the textile that's not a polyester, will be a waste material, because we'll be recycling the polyester component of that material. And so I think that's a long way of saying I think we've got a long way to go before we even begin. And it's not going to be just Eastman, it's not going to be just Dow, it's going to be the entire industry focused on solving this problem.
Maybe a quick comment on that, trying to put the polyolefin or polyethylene perspective on that. If you look at Europe, and we are not trying to project a growth of plastic consumption, let's stay with what we have today. We have roughly 9 million tons of polyolefins in food contact, whether that is a bottle, whether that is a film that is protecting food. And if you think of that, and then depending on the ambition that we have to have recycled content in those, you can run the numbers for 10, for 20, for 30%. Right. And with the ambition of replacing fossil feedstocks, we would want to have that at a meaningful number. What that meaningful number is, we can all debate, but it for sure, if you look at the scale, 10% would be 900,000 tons. If we are building now the first level of these plants, they are they are at modular level, let's say 50 KT. So that means we still have some way to go to actually achieve these kind of ambitions. And also Christian was commenting on that the material is not yet there. So currently I would say we are not at the level that we actually can supply what is actually needed, and that needs to happen over the next year. So the other point that I wanted to also throw in the ring here is that if we look at legal recognition, that was discussed a lot, if it is specific for polyester, it is probably good for your objectives and your framework, but we need to think in the delegated acts as well for the larger scale of polyolefins and food contact materials there. if we don't get that kind of legal recognition, then we will have a delay in the build-up of that. And Nestle has maybe not the material available, and some other material or companies will not have the recycled content to provide for food contact on the market. So if we look at that scale, these are, and globally, it's also an affordability point, right? I mean, you invest, you need to see how you eventually can build the investment case for it. And not even considering plastic growth, there's a lot of things that we need to do complementary to bio-based. I mean, there's some studies that show if you want to reshaping plastics, a report that was published by SystemIQ, or as well some other studies, scientific literature, science papers, saying that if you want to have a mix of bio-based and chemical recycling plus mechanical recycling, you need to really scale up a system to a much larger level than it's at today.
Yeah. If I may make a comment as
Yes.
well from the perspective of the Commission. Indeed, I hear what you are saying, and this is a matter. I mean, there are a number of elements of concern and interest from us, from what we have heard here, and we are. I have heard also the comments about the mass balance, and I would like to confirm that this is a method. I think we are considering, and I mean, without anticipating, of course, a final decision, because that will be taken at the right moment. We don't want to keep you on your toes, and to say, I would like to say that, confirm that mass balance is a method that we are having, taking in mind. Indeed, we are aware of the problem of the insufficiency of recyclables on the market, which is particularly relevant, maybe not for everybody, but for a good number of actors. And I think here two elements play a role, maybe not necessarily in the logical order. Indeed, mandatory recycled content, which will contribute as catalyzer for the creation of a market, because you create the demand, or you stimulate the demand, and of course the provision. How do you do the provision? The provision is improving separate collection and recycling from the consumers and from the economic operators, or the generators of waste. And this is a little bit of a bottleneck here, and the Commission will come in a few months with the so-called early warning reports about the performance of the member states on recycling and landfilling and the recycling of packaging waste, and the situation is not good at all. I will not now enter into details, because again, the details will be available in April, when we hope to have the college adopting this. But the situation, I mean, also it's not a big secret, and member states, we have discussed with them, they are aware individually about how they perform. There are data, statistics from Eurostat which are available. So more than half of member states underperform under several criteria. This means that we need to do something about the improvement of separate collection, not only about plastics, but also about other materials. Of course, there is a problem, and we need to reflect, and we are reflecting. But when I say we, it's not only about the Commission, it's also about, of course, the European Parliament, the authorities in the member states, and more generally the economic actors, about landfilling. How much are we going to allow landfilling?
No.
And yes, this is an idea which appears more and more forcefully, and yes, those member states in particular which hugely underperform in the area of landfilling need to think. And we need to think also about striking maybe a better balance about waste to energy without encouraging overcapacity. Of course, a number of member states have developed already overcapacity.
Yes.
And they are absorbing
It
the
exists already, though.
Others, in particular the member states which are more challenged from the perspective of landfilling, have not yet developed enough capacity on waste to energy. But in the situation of improving selective collection and recycling and creating more widespread obligations of mandatory recycled content, how much do we want also to give more positive signals on waste to energy? Do we really need to give more signals? So these are topics for reflection, because we have a part of the industry, which is of course not your industry, which says, "Oh, Commission, you need to do something," and member states, including some of those which we know best, we take Commission, come and talk to us, etc. So there are a number, I would like to, of satellite issues which are not secondary as importance, but which are connected to this, and we need to think about the ecosystem and how you reorient this system, not in a century, but not from a day to another either, because investments are necessary. So and one caveat as well. So because there was a plea also from Nestlé, from people whom we have met, along with other actors around this table, the recognition of the method, the recognition of chemical recycling for the mandatory recycled content, yes, but I would say, not only as a lawyer, I would draw your attention to a provision maybe known by many, Article 3, paragraph 17 of the Waste Framework Directive, which clearly says recycling as not including energy recovery and the reprocessing into materials that are to be used as fuels or for backfilling operations. So what goes into backfilling and into fuel does not count as recycling.
Yeah. And if I may now publish my question or commentary, it's a bit bigger one, and I hope that you could stay still
Yes,
a second.
I will be back in 30 seconds.
Yeah, good. Because I hope that you could comment also. First of all, yes, I think that we should be much stricter on the waste to energy. And the reason for that is, and to have a strong lobby on this, the reason is that it is a sidetrack. We've noticed it in many member states. While you create it, you have the pull effect. And you have all the municipalities and all the industries and those who are dependent on that energy willing to feed the facility. And so it's very hard then to close the facility and cut off the naval cord to that. And I'm very flexible for certain intermediate period on exporting waste wherever within the Europe for incineration, in case that there is not the capacity in that moment, but only for like 2 years or 5 years or 10 years, depending on the city or the situation. So to give the time to manage and create a new system. But that was the comment. Then, if I get it right, and this is why we organized this whole discussion, and we try to be in the Parliament and hopefully in Commission as clear and precise as we can. We all agree about this reduce, reuse, and design out of the waste principle. So all the plastics that are produced from day X should be like PET bottles in the Nordics. Something that is produced comes, and if it is not reused, like it doesn't make sense, it is reproduced. And the figures, as you know, are actually staggering good. we are talking about over 80, over 90% of return and reuse. And this is the scale what we should sort of benchmark to. But that is the whole design. It is, everybody is using the same material, right? It has a deposit system. It comes clean. And while you have the whole big market, it's easy to collect and reprocess and then to reuse the whole stuff. So it works. But we can't probably create that kind of a systems for, let's say, 250 or 1,000 different separate collections. And that is the big question. Which entities we should separate collect? Are there entities that are clearly products that we just would allow the producers to decide? The PET bottles in Nordics are not waste, they are products. So it's up to the business to plan how they figure out how the system works. Should we do it the same with the matrices and to say that, look, if you in the regulation that if the industry ecosystem itself can provide safe and closed loop circulation beyond 85% or beyond 90%, it's up to them. And then only if you can't do it within 5 years or something, then comes the sort of a separate collection of the regulation or the others. Because I think that we would need to have that kind of a time to test different models. I'm not sure if we should separate collect all Michelin tires and PET bottles and mattresses, and is it IKEA the right place to do it or what? But I'm not sure that the collective waste treatment is always the most best place to do it. This is something I hope that if you do not have all the answers right now, you could then come back when we deal with that. Well, then secondly, there are plastics and plastics, I get it. Well, that makes it sort of difficult because in your system you can't pour all the PVCs and all types of the plastics what you can get, and then to get over 90% of return and reuse, right?
That's correct.
Yeah.
Polymer renewal technology is specific to polyester.
Exactly.
In our chemical or our carbon renewal technology, we can take a much wider range of material, in fact, everything but PVC.
Yeah.
In that technology.
Yeah, then probably we would need to sort of have in delegated acts or in the regulation, this kind of a thinking. What kind of ecosystem do we need? And as I gather it, there are the polyesters. Textiles might be easier than what we think because there's a lot of very good plans in mechanical recycling. And what does not work there is this kind of underwear and sports stuff. And that actually goes very easily, if I get it right, to polyesters. So maybe there should be this kind of a combination ecosystem of 2 or 3 different kind of business actors doing it and pretty close to each other. So how many do we need? Do we need in all of the member states or 2 in Europe? Because it's a massive scale. This is something, of course, up to the business, but we should have some guidance because it needs to be effective, environmental and business-wise. Then the PET is, of course, one, and then there are the RPTs. Then do you want to mix the biomaterials, bioplastics or not? I'm not the specialist here. And then the big that is Miriam's headache and ours too. What do you do with the legacy materials? Whose task is that? Where do you fit that? No, it's not incineration. Someone now looking towards the Dow would need to figure out the system, how you sort of put back to the molecules and bits and pieces, the old stuff that we have all at our homes with plenty. And then in renovation or when we move or whatever, there are, I don't know, huge amounts. I guess I had at least 20 or 50 kilos, I don't know, different kind of a plastic if you just sort of pull it together. At some point it's going to come to recycling.
Yes.
And we should,
Chemical recycling.
yeah. And well, that is so how to sort of build this picture so that everybody is clear in the same page. And now I'm going to the member states because they all have their own systems, and of course everybody says our system is best. But can you create effective system with very diverse collection systems and traditions in member states? Or should we really start this fight that this is a European business now? And there I had another point, and this is the metering. I had the huge row when we renewed the waste framework directive, because I think that we should have compulsory the metering of and indicators of the recycling. The first point is when you collect it, so you know if you get it or you don't get it. The second point is when it enters a facility. You know, did it enter to a facility or did someone burn it or did it go to a landfill or whatever? Or did someone export it? And the idea is that it should circle in Europe. The third point, of course, is what comes out of the facility. What is the effective ratio? If the mattresses are weight and the papers are dumped and on mold, they are thrown away because can't reproduce them. So the system is failing. And then the last point is, of course, when you get the effective material, how much of it is used? Because we all know that at least today you do all this stuff and then you get the materials and no one buys it, and then it ends up to incineration or somewhere. And at least we should have almost real-time understanding of member states and businesses, and it probably would facilitate to make the investment seeing, okay, here we have a sort of a window of opportunity to do something, and here we might have overcapacity and we'll need to sort of connect some other member states there. So I might be totally lost, but this is what I'm trying to figure out, and I understand that we can come back probably a couple of times to be really clear in Parliament's recital probably of how do you define this recycling is not incineration. And that it needs to have effective use ratio at least beyond 70 or something of that polyester or that PVC to call it recycling.
Yeah.
And not sort of a producing fuel or being just basically incineration or, you know, the millions of other sort of push-ups here and there. So this is what I would like to have your help.
So maybe a couple of comments, just to respond. So a couple of things. So one, let's go back to the bottle-to-bottle recycling that's being done exceptionally well in the Nordic region. There's an interesting study out of Sweden where even in that closed-loop system, they have to add back 30% virgin material to maintain the performance of the bottle over time, so that you don't once chemical recycling is in place, that can replace fossil fuel to virgin material. It can become the material that elevates or keeps the performance of the mechanical recycled material up. So that's one thing to think about. Another thing, you were talking about partnerships and how industry and government work together and think. So let's think about pyrolysis and methanolysis or polymer renewal technology. They're highly complementary. On the front end of our process, we will separate out very intentionally the olefins. And the folks that do pyrolysis would very, very much like to separate out the PET from the polyolefin, because the more oxygenated materials that go into pyrolysis, the less efficient the pyrolysis process. And so pyrolysis chemical recycling, methanolysis chemical recycling take the two largest packaging plastics, and they're very, very complementary to one another. And so when companies like Dow and like Eastman separate the polyester from the polyolefin, if those two technologies exist regionally, you simply transfer the olefin material from Eastman to pyrolysis, and from the polyester material from a Dow to an Eastman, or that can be managed at a partner waste handling situation. And so just wanted the group to be aware, not only is molecular recycling, mechanical recycling and chemical recycling complementary, the different types of chemical recycling, if you plan it and manage it strategically, are also very, very complementary. And then the final point I wanted to just give some initial thought, because this is a tough question that you posed around how do you think about what categories of materials to collect, and how you, one of the things that I would suggest is we think about it in the context of durable things, so a mattress and flooring, things that get used for whether it's 5-10 years or, like as you suggested, 20+ years in flooring. The collection of those durable materials would be very different and managed very differently, and probably could be leveraged by retailers, brands, etc. Whereas packaging materials that find their way more times than not either into homes, restaurants, things like that, need to be managed in the more traditional, I'll call it home collection or industrial collection, and then routed to facilities they call mixed plastic processing facilities that will then separate those materials and send the olefins to pyrolysis and send the polyesters to polymer renewal technology. So I think thinking about it in those terms, at least at the highest level, is the best way to think about it.
I think the waste streams, and as you mentioned, Chris, if you have discrete objects that are larger and clearer to identify, not an everyday, let's say, good, we need to think through as specific streams that we try to collect, like Chico is doing, right? So these are, I think, relative. PET bottles are also clearly distinct, and a lot of people understand it. If it comes to all the different foods that we're packaging, there are lots of different variations in that, and that, in our view, or at least my view, let's put it my view, is the point that we have to do work the systems that we're using, where we have household discharge, possibly a yellow bin or a specific collection for plastics, but then that also needs to have the right incentives, because what you see, for example, in Germany, that you have the refuse bags being paid for, and often the yellow bin is free of charge, or let's say at least freer of charge, is a different cost system, and people put more into the yellow bin as well, in the yellow bag, because it's eventually cheaper. So there is the incentives need to be right to put the right stuff into the right system for us then to collect and sort it out, so that then what can go to mechanical recycling goes, and the 10% of plastic in the municipal solid waste, average speaking, is also not there because it should be there, right? It is there because people put things in there, and no, I don't say lazy, but it's basically.
No, I'm lazy. no, not me. My spouse is lazy.
No, but I think there's also what I'm saying in a way is the system can't be a one-size-fits-all. I think that is a risk for the overall system, because then you will have a lot of things falling through the cracks. But we need to strive for a very high target of recycling rate, so that we are not. But all these processes are also different. If you do mechanical recycling, there's also a yield factor of what actually comes out of the facility, as you explained. The same is true in all of the processes. So in that respect, that is another element where a 70 or 80, obviously we strive for that, may not be the right number for everything. So in some processes you will get probably to 90. In other processes you may still be at 65. I don't know what the right number is, right? But it basically is all should be purpose driven. What do we want to achieve in the end? We want to have a higher recycling rate and less waste.
If I may jump also on the purpose, we are speaking a lot on like dealing with waste, but what we see, and there is a recent study presented by Minderu on this, is that the amount of single-use plastic waste has increased around 1 kilo per person between 2019 and 2021. So I think if I also have to really take into account that the prevention part is really important, and also we are speaking about chemical recycling has to scale up, but there is also all the system around reuse that has to be scaled up at the same time. So I think there's also this two consideration to have in the room, because now we're speaking really about the technology and the answer, but do we really need all of this plastic in the first place? We see a lot of, as I said, single-use plastic waste being increasing, also all the packaging that we are literally taking, using, and then throwing away. I mean, that's not real circularity. I mean, real circularity would mean keeping it in the system, so reusing products. So I think that's also something to keep in mind. The reuse part is really part of the zero waste society, because, I mean, zero waste means not having a waste at first, in the first place. So this is something to really have into account when we are speaking about recycling and the plastic issue, because it's, I mean, plastic is everywhere nowadays, and we acknowledge what it has bring towards the health and also all some of the conservation part. But it was also, I mean, we then, there was also a lot of parts present in plastic, so it has also to be taken into account, really, to really assess when we need plastic, and then finding either not using plastic or other type of material as well. So I think this is also a question that we need really to have a broader approach and really taking a step back in this discussion as well.
If you can relate to that, I think this is.
Shall I go?
Yeah, go.
Yeah, okay. Thank you, Silva. Yeah. This is Vasilis Zoulis from SEPS, Help Sustainable Resources. Thanks for the invitation, by the way. I think it's a good time to have a discussion on it. Silva, you will agree that sometimes the discussions around circular economy is not as simple as people think, circular versus linear, because our knowledge about what is circular, what is linear also evolves. And following this debate for quite some time, I mean, I'm neither a lawyer nor a chemical scientist, I'm an environmental economist. I would say that
Nobody is perfect.
I would say that in our view, if we move ahead a little bit from beyond the debate on plastic to fuel, as we had earlier, I think a key question that many people struggle with, including ourselves and researchers in this domain, is that while most of the actors, companies, NGOs, academics will agree that we need real solutions, and very few people, I think, will disagree on this. And really, if you look into the technologies, even if you know the scientists, you will see they have different advantages and disadvantages also because of the complexity of plastics. It's not like other material things. But the key question is what kind of framework we can put in place that, on the one hand, ensures a level playing field, a term we use maybe a little bit too often in this town, but still, while at the same time ensures that the feedstock fits for higher rankings in the waste hierarchy does not end up in lower rankings. Basically, the issue we have with incineration. I think that's the key question. And of course, very often we hear from people that the economics might do the job, and it's not going to happen. But of course, the economics might be different in the future. Innovation might be changed in the future. So I think that's the key question that a lot of people in this town are struggling with. What rules we can put in place that really gives room to all technologies while we avoid this kind of risks. And of course, any ideas from the industry or other actors on the table, I think, will be of benefit for all of us, including the Commission.
What I want to nicely compliment, I think I see different concerns. One concern is that the industry is saying, well, we need some certainty, we're going to invest a lot of money, we want to make sure that we are going to make some profit out of it. At the same time, there is a concern from civil society is that, well, isn't this another incineration where, it might help with something, but it's not going to represent everything, and we're forgetting about the very beginning of prevention. And for me, what we need to try to end up with is really having the comprehensive view, because indeed we have a huge problem with too much plastic. The economy doesn't work because we don't count in the external costs that we are offloading on, environment, our own health, honestly. This is something which we need to try to adjust. But I think what is going to be crucial is how to actually also in the kind of policy area to align more the forces, because what I hear from the industry is actually at the moment not looking like a lot of overcapacity. It's actually still feeling what the elementary things that we need. But you need to win the trust by saying that, by basically supporting the fact that actually we need less plastic overall. And there is so much plastic waste that your business is there for years to come, pretty much guaranteed, just dealing with the waste that we already have. And how to, with the upstream sector, with all the users, try to build it into coherent business model that it's gonna work and not offload the costs on planet and humans. And I don't have the answer, but I think the really good thing is that we talk about how we can build the answer together.
I think one of the challenges that you raise is how do you deal as a society with this challenge? Because I also care, I mean, I studied briefly chemical or environmental engineering and I have a passion for it. On the other hand, the point is how do we deal with that as a society? Because if you say we don't want plastics or we limit plastics production, which is of course being discussed globally, is that a solution to how humans behave? Or how do we deal with it? It's a very complex question and I don't have the answer for it. I need to admit to that. But I think it's a really complicated, interrelated, a lot of discussion requiring question of how do we secure lifestyle of what we want or what everybody seems to want, not maybe everybody, but a lot of people. And how do you create a better system that avoids contamination and all these kind of elements, and where do you start building that system?
Yeah, I mean, you hit on a key issue, human behavior change. And you know, we saw it in our business in a very small, narrow area. But back a decade ago or so, we innovated around these durable plastic sports water bottles that you can carry around and use for thousands of fills. So that's an example of where, as a result of the innovation in the sports bottle area, a whole lot less of this, even though it may have grown over time, it grew less over time as a result of that innovation. And part of the polymer renewal technology that we're deploying, both in France and in the US, is dedicated towards taking packaging waste and converting it to durable end products, medical device application, reusable sports water bottles, Rubbermaid and Tupperware food storage containers, so that you can now store and rewash and reuse literally hundreds or thousands of times, which is at least a way where you can change behavior in society by taking a packaging material and get people comfortable with using a durable material. And I think the way you have to do that is almost application by application, because it involves human behavior change. But we're in the business of changing people's behavior. When we talk about marketing, you hear the word marketing. Marketing in business means you're intentionally trying to change the behavior of a consumer or of a B2B customer from buying this product they used to buy to this new product. That's something that we do, for a living as industry. So I think we can get at that one application at a time. It's not going to happen overnight because the average consumer is used to consuming in a certain way, but it can be changed, because I've seen 2 or 3 examples of it just in the business that we conduct.
Absolutely.
We had one comment, did we, on the line?
We have a lot of questions, Silpa, and what I was going to suggest is, since we're running out of time, but not to let these questions go to waste, what I will do is I will put them in a document and I will share them with the speakers.
And if you would be kind, yes.
No obligation, but you can reply, and we'll put that on our website, and I will send your replies to the person who asked the question individually as well.
Okay. Okay, that sounds
maybe share the website with the people that asked, because people ask different questions and don't repeat because someone else does. But
Mm.
no, I think it's
Yeah.
a great idea. Thank
That
you.
would be a good and a fair idea, and so everybody can sort of enjoy the questions and answers. Well, it has been certainly a good discussion, and I hope that we'll continue this and quite a number of other discussions. And yes, what makes this so exciting and difficult is that it is a paradigm change. Now we around this table get it that the globe is a ball, it's a round, so we can talk about sailing around it. Sometimes we do have problems of talking to those people who still think it is flat, because they are not so excited about our circular economy ideas. They find them a bit strange or that dangerous even in some cases. But that we get it doesn't mean that we know what is in the other side of the ball. And this is what we are doing together now. There's a lot of questions, and what we can bet is that we are going to make mistakes and going to fix the system later on. It's learning by doing, but we certainly must avoid certain very sure mistakes, and these are the sidetracks. Quite often when you have a new system, and public sector sometimes is very good at this, is that you think that now when you have a car and it competes with horses, so you put the rollers on the horse's legs or the wheels on the horse's leg, and then you wonder why it doesn't work. And this is a bit the same system that if you try to the linear-based thinking, and this is the incineration, and there's always stuff to be landfill. You won't go any faster or better, and we have to invite this, and there's a lot of interesting questions like what is the definition of a product and waste, what kind of a business ecosystems do we need, certainly it needs to be European, how do we combine, I learned quite a lot of things. For example, this classification, which has different plastics working together. It can be sorting, mechanical sorting also. And then the durables versus this kind of a short-term packing usage.
Yes.
There are
and
technological
yeah.
solutions which have been developed
Yeah.
for sorting,
Yeah.
watermarking and
Yes, and product passes
Yes,
and all this. So there are a lot of things. And then actually, if there are a lot of movers and shakers, I think that it'll prevail pretty fast. Actually, the mobile phones did. But if you would have had a committee and the politicians to decide that we sort of erase the landlines and have a mobile phones, probably we would still be sitting and thinking whether we should go there or not. So the problem is, how do we convince our colleagues, the politicians and others, that now it is time to take a bold and brave steps? It's good for the business, good for the planet, good for the people, good for the innovation, and on the end for the consumers. The life isn't going to be less nice, it's going to be much nicer than what it is now. So very glad and excited to be in this path and in this work with you people. Thank you.
Thank you for organizing.
And thank you for once again taking the responsibility.